Buffers are temporary spaces in your computer used to speed up reading and writing data. It attempts to reduce the difference between the input speed and the output speed. They are a way for us to allocate memory, fill it with data, and consume it later. Use it to prevent going back and forth to the source asking for more data necessarily. Bringing to our context, imagine that you are reading a 1 GB CSV file. Instead of putting the whole file data in memory, you would read it on demand. Although you wouldn't read byte by byte, as you have a good amount of RAM available to use to process your program. You would instead process, let's say, 10 megabytes of data per time. In other words, you allocate 10 megabytes of data into a buffer object, consume it and discard it, and then you ask for more data and repeat the process. The key concept behind streams in general is to read and process data on demand. That's how object buffers become handy. It reads an amount of data and puts it on a buffer object with a fixed size. After consuming the buffer content, it can discard it and read more data, allocating it to another buffer object. Spoiler alert, that's how you can process terabytes of data in Node.js. I prepared 2 examples for you to show how to interact with buffers manually, the main concepts, and how to simulate what Node.js streams do behind the scenes to consume data. Enough talking, right? Then let's get started. All right, so let's start creating our class for this module. It's the second demo for buffers. And I'm gonna start talking about the buffer API. Okay, so for the buffer API, let's talk about what's a buffer in practice, okay? So buffer will be our global buffer, okay? And we could alloc data. So when we use alloc, we are just grabbing some memory from our operating system so we can fill it with other data or replace the data that's already here, okay? All right, so now I'm gonna fill it, okay, with 2 words, and I will fill it from 0 to 2, okay? So here you can notice that we have 5 positions, right? So it's 5 bytes, if I'm not wrong. And from 0 to 2, I'm gonna replace it with high. We could use also hexadecimals. So we could fill it with 0x3a, okay? From 2 to 3, so just so you know, hexadecimal, char code for the signal, okay? Nice, nice, nice. What if I try console this buffer? Let's see what happens. So I'm gonna go to the second folder, node 1. Okay, now we can see that some of data is there, but some of like the rest is 0, all right? What if I try to use here toString? What happens? Ooh, we can see the result as a string, right? So our hexadecimal was converted for the signal I just told you, okay? All right, so we could try another one. So I'm gonna put this right here, and we can see that we could put more data, all right, but we are not using it. So we are using from 0 to 3, but we could use from 0 to 5, all right? So let's try filling this buffer. Okay, another hexadecimal, so we can show more examples later. So this one is hexadecimal, char code for this signal, parentheses, okay? If I try running it, you can see more and more data coming, okay? But what if I try to use the same idea and try to fill more? So maybe from 5 to 6. And I don't know, let's put some letter here and let's see what happens. So when I try doing this, we can see that a buffer, we just exceeded the size, right? It's out of range. So when we use buffers, we have actually to allocate data and use that allocation, all right? Otherwise, we can move the data to another buffer, which is we could do right now. So I will just comment here, and I will put here error when it reaches max value. It should be moved to another buffer, right? So how do we move to another buffer? Easy. I'm gonna alloc another buffer, and I'm gonna use the same idea, alloc. So now it will be 6 bytes, okay? And then we could use the set method to get our previous buffer and say how many positions it will use. So we're gonna use the byte offset. Byte offset. So now instead of buffer, we could see, I'm gonna let this here so you won't gonna miss the logs, okay? And then we can see the results. So let's try again. And now everything's working with our previous buffer, but now see that I'm referencing the new one, okay? Well, because I have more slots to use, I can actually try filling it with another data, okay? Let's try doing one experiment. What if I try to fill it with 4 bytes? Why 4? Because here you can see that I'm selecting 4 letters, right? So it's 4 bytes. However, I will use from 5 to 6, okay? Because it's the remaining bytes I can use from here. What do you think is gonna happen, my friend? Will it crash? Will it save? What's gonna happen? Let's see. If I run this data, you can see that it got only the first letter. So it's just filling it, grabbing the whole string, but it's just using the amount of data that we are actually referencing here for our buffer, okay? So every time we want to move or extend a buffer, we have to create another, move the data, and so on. This is very rare to do, being honest. I actually haven't seen this in production. I actually did this when I was trying to recreate the WebSocket API from scratch, and I had to move buffers, work with binaries, and so on. But I would say in production, you're gonna see this very rare, okay? Nice. What else we could do here? Well, we could just print this data so we can see the difference, right? So I'm gonna do buffer and buffer to string. Then I'll do the buffer so we can be aware of what's going there. And I'm gonna use the byte length, okay? So if I run there, we can see that the string is one thing, the buffer is another, and the byte length, it's something completely different, right? So we have 1, 2, 3, 4 bytes maybe, or 4 strings, but we are actually using 5, all right? 5 bytes for it. Perfect, perfect. What else? Well, we could do the same thing for our another buffer so we can see the difference. So now you could notice that our buffer has more positions here, okay? Nice. You're gonna relate it more when we're using streams for it, but yeah, we're gonna go there, okay? Well, what if I try to, instead of filling by positions, I could fill with the whole thing. So, or with full data. So here, const message, maybe hey there. And I'm gonna see const pre allocated buffer.alloc, okay? And now I'm gonna alloc the message length, and then I'm gonna fill with data. Nice, isn't it? So we had like 4 lines for 4 or 5 lines for it, and now we could do by one line only. So I'm gonna copy paste and see the result now. So I'm gonna run again, and we can see with the pre-allocated data we can have more bytes, right? And now we have 10 because we have the whole string there. Well, usually when we are trying to allocate from a string, we usually use the buffer from. I'm gonna use this later, okay? I'm gonna show more examples, but it's same thing of buffer.from message, okay? Yeah, I mean, let's see, with buffer from, okay? It's even easier. This is actually what we usually use in production. So I'm gonna do the same thing, and now with our buffer from. Okay, you could see the values here are exactly the same thing because behind the scenes they are executing the same idea. Okay. Okay, do you remember that I told you that we can use hexadecimal, right? These numbers are machine code that is actually translated to our code. So let's try and do this more often, more some advanced example, so we can get more excited about this. So I'm gonna grab hello world, okay, and what I'm gonna do is I'm gonna iterate. Let me just move this here. Const index in string, okay, and notice that each string has a char code, right? So I'm gonna use char code at index. Okay, so now we could print this code. Let's see what we have there. So, oops, it's char code at, not char. Now we can see numbers as decimals, right? So here we were using hexadecimal with 0 and then now we are using decimals, okay? So integers, decimals. Why we are going using decimals? Wait, we're gonna go there. Well, we are trying to actually represent the same binary code that we are saying here in hexadecimal. So I'm gonna use const bytecode, and I'm gonna keep the OX. I'm gonna use math abs in this code, and I'm gonna do the toString 16. Don't ask me why this count, okay, because I just copy paste from Stack Overflow to make this class easier, okay? But don't worry. This is just to show you that you can create buffers from hexadecimal codes as well, okay? So now if we take a look here, you can see that we have that representation in hexadecimal as I was using here, okay? Well, what we could do with it? Well, we could actually create an array here, char codes, const bytes, and I'm gonna save both, okay? So char codes, push code, and bytes, push byte code, okay? Nice. Well, I'm gonna try printing here all the representations, trying to print in decimals, in hexadecimals, in string, and the buffer, okay? So how can we do that? Let's put a console.log, char codes, bytes, okay? And then content from char. So how do we get content from a char, okay? From char codes, actually. Char codes, easier. So I'm gonna use buffer from, and I'm gonna use char codes, and then I can use toString. See, I'm using char codes for this example, right? The decimal ones. So if I save it and try running, we can see here the content is hello world, okay? So we are using this char codes, and these char codes were parsed to our string, okay? We could do the same thing from for our bytes, okay? Content from exabytes, but it's missing an H, exabytes. Same thing, buffer from bytes to string, okay? So now we can see that we can use both representations to our code, okay? So what I mean here, now we can use decimals, hexadecimals, and strings to work with buffers if you want, okay? For the next example, now that you got an overview about the buffers, I'm gonna try doing what Node.js do behind the scenes, what I explained to you when you try to split data into buffers, okay? So let's create a second example. It will be strings buffers MJS, okay? I'm gonna move here so you can see the file name. Okay, first of all, I'm gonna create a very big file from here, from our terminal, okay? So I think this code is gonna work only on Linux and Mac. I'm not sure if you are working on Windows, but if you are working on Windows, try using WSUL, okay? WSL could be easier to work with bash commands. All right, so here I'm gonna write the whole command and then we see this working, okay? So I'm gonna use sequence from 1 to 100, okay? And then I'm gonna run this for on our terminal to actually fill a file with data, okay? So I'm gonna run do node. I'm gonna use the E to evaluate. I'm gonna use process stdout.write, okay? And then I'm gonna use that I for the index, and I'm gonna write some random world here, okay? So hello world and /n, and with this output, I'm gonna move to a text file, okay? And done. With this whole command, we're gonna run 100 times, writing this whole thing, okay, to the text file. We can increase it to create bigger files later, but I'm gonna do this just to see a simple example, okay? So here I'm on the folder. I think I have some wrong operator here. For I, it's missing the I here. See, that's taking a bit long to run the code, but if you try going to the text file, now we have 100 positions, okay? You could think this with a lot more, and we can see how big is this size here. So it's just a few kilobytes, okay? Okay, let's suppose that this file should be like 5 gigabytes, okay? In the next class, we're gonna work with big files, but from this class, I just want to share you how Node.js would split this whole file into buffers and process it on demand, okay? So going back to our file, let's import from fs promises, and I'm gonna get the read file, okay? Just an example. So I'm gonna grab the whole data here and I'm gonna read this file, which is our text, okay? I'm gonna do the toString, and then I'm gonna split it by the break line, okay? Because we have break lines here, so each one of these, so we have maybe an array with 100 positions. Perfect. Well, let's comment it so you won't wanna miss it, okay? If it's a big file, it's a big file, it would crash or make your program slow down. Gonna fix it in the next class with Node.js streams, okay? What I mean with it, This read file is not a good practice when we are working with big files, such as more than 2 gigabytes file, okay? But for this class, I'm just wanna try reproducing what Node.js is doing behind the scenes. So I'm gonna put the whole content file in memory, gonna split it, parse it into buffers, and we can see small files, okay? It's gonna be fun. So we have a file here with 100 positions, okay? So I'm gonna process 10 items per time, okay? So const lines per iteration would be 10. Okay, nice. I'm gonna say how many iterations we have will be the data length divided by our lines per interaction. Okay, and this time we know it's 10 in 10 lines, not bytes. Okay, I'm saying not bytes because Node.js works using bytes, but for this example, simple example, we're gonna use lines. Nice. Well, I'm gonna try paginating data. So I'm gonna use page and then I'm gonna run our let index 0, index less iterations, index plus plus. Simpler, right? Nice. Now remember that I told you that our buffer are cut in small pieces. Small pieces are called chunks that we're gonna see in the next class. But let's just go further. Our chunk will be our data, split, right, by the page, and the page is gonna receive our lines per interaction, and we're gonna put them all into the same line. So what I'm gonna do here, I'm gonna grab 10 lines, okay, and then I'm gonna move to the next page. So in the first interaction, I'm gonna grab 10, and then in the first interaction, more 10, and so on, okay? Easy peasy. Nice. And now, I told you in the last class that our Node.js has a internal buffer, right? So imagine this as the maximum 2 gigabytes buffer Node.js can handle per time. Okay, this is the maximum Node.js can handle, and Node.js does this behind the scenes. Okay, this will be our buffer. Okay, so buffer from, as I said to you, it's commonly used buffer from. And now imagine that we have this whole file, we have the piece of the buffer here. We can send it to someone else, process it, and then when we finish processing it, it's go back to the loop and send more and more data. So in this case, in this interaction, we will have amount of bytes equals buffer byte offset. We will have the buffer data, which will be the buffer toString, and I'm gonna split it again in break lines. Why? Because now I have already these 10 lines, all right? So they are all in a single line, and now I'm gonna split them again, bringing it to an array, okay? Nice. Okay, so how many lines we have? Amount of lines will be the buffer data dot length, which will be an array for us, okay? Now, I'm gonna comment here. Now the buffer data would be split into small pieces, even smaller, right? Pieces, and processed individually. Let me move here so I won't be on demand. Okay, now imagine I'm just gonna console it, processing buffer data. How many lines do we have? Amount of lines, and then the amount of bytes we are processing. If we try running this one, we can see what Node.js, here, processing buffer data. All right, it seems it's working fine, right? So here we have our chunks, our pieces, 10 lines, but see that we have one line that has anything. That's because our index starts on 1, not 0, right? So I'm gonna put 1 here, and then we should see everything works fine, okay? Now, we could start wondering how Node.js is working behind the scenes. We get a big file or a big amount of data, we split it into buffers or into a big buffer, and then we can split it even more, and then we can start processing and sending data as we want, okay? Something important here is that our buffer is allocating memory to use in the future. Ooh, very nice, exciting, right? Honestly, this is just an experiment, all right? We won't do this by hand at the end. But I really want you to know how Node.js would be working behind the scenes. So you might think, okay, it's a buffer, it's using memory. That's why it's so good. That's why we can use infinite data. That's why we can consume the random on the Linux, right? The /dev, I think, and random, it's an infinite file that we can consume in the Node.js, and you're gonna see you can consume it forever. As long as we're gonna keep this data and we are processing, when we finish processing it, we can ask for more as an interaction is working, okay? Notice that in Node.js we have two different ways to allocate buffers: the buffer alloc and buffer alloc unsafe. The alloc unsafe is safer and it allocates memory that is being discarded. However, this data would contain secret data, which means an attacker can read your data such as Node.js credentials, environment, and more. It's a remote memory exposure. So what people usually do is use alloc unsafe and make sure to fill all the data with zeros before using it, or to fill all the buffer with data before sending to customers. In the next class, I'll finally introduce you what are Node.js streams and stream types so you can start using it right away. Don't forget to evaluate this class clicking on the star below, and if you have any questions, use our comment sections or our Discord channel to discuss it with other students. I'm sure they would learn a lot from your questions and would love to chat with you. I hope this class has exceeded your expectations. I'm Eric Wendell, and I will see you in the next video.